Hello Stats class, here's the summary chart for Chapter 12, and I might do this live also depending on what people want during class, but here's a video if you missed the live version. So, we have done two basic new inference things in this chapter. We've done confidence intervals for slope, and we've done significance tests for slope. And so if you need to know this, it was lesson 12.1b and 12.1c that we learned these two procedures. And beta is our parameter. It is the true population slope of, you put your two variables, and usually the response variable goes first. Response variable versus the explanatory variable. So on the state step, you would state that parameter and you would name the confidence level, which is called C, or the significance level, which is called alpha. And if it's a confidence interval, you don't need hypotheses. If it is a significance test, then you do, and it would be, your null hypothesis would be beta equals 0, almost always 0 in that spot. And then beta could be either not equal to 0 or less than or greater than 0. Computer output always assumes the not equals, and I forgot to mention that in the other notes, that whatever you read on the computer output is the p-value for the not equals, which is doubled, and then if you don't want it doubled, you'd have to cut it in half, of course. Plus, you'd want the context, which would be your definition of beta. All right, so both of these are based on t. It's a t interval or a t-test for the slope of a least, LSRL stands for least squares regression line, which we first learned in Chapter 3, a long time ago. And I'll go ahead and write it twice. You can write it twice if you want to, or you could just write one of them. Oops, I just wrote it wrong. Well, if you're going to write it twice, write it right. It's squares, least squares regression line. All right. The context, or the conditions, are the same for both, and that's why it's one big box instead of a little box. So they are, the book puts these in order as linear. I like them in this order because it's the three familiar ones in order by importance, and then the two extras you choose. I'm going to put the names of them first. Random, normal, independent, linear, and equal variance. We learned those technically in lesson 12.1a because I didn't think there'd be time for that in B. So all of these, you need to know how to check them. You don't just make the list, you check it. Random should be given. You're checking to see if it's given. Normal is where you look at the residuals, and it's going to be either a box plot, dot plot, histogram, box plot or dot plot or histogram of the residuals. And it needs to be not too skewed. We're not being super picky. And then you also might look at a normal probability plot, and pretty much on the quiz, I'm going to tell you, I'm going to give you the graphs that you need, and you'll just need to decide which one is appropriate for each one. So you won't need to make the graphs yourself, but you will need to tell me which graph you're looking at. If you're looking at a normal probability plot, you're looking to see if it's approximately linear. And that would mean that the original residuals were normal. If you're doing this on a project, which eventually you will, hint, hint, you'll do it with your calculator, and then you'll have to decide which plot you're going to make to check the residuals. Independent is the same as we've always done. If it's a sample, we need the sample to be less than 10% of the population. That's pretty easy to check. Or if it's an experiment, we would need randomly assigned treatments for this. Linear and equal variance are two more where you have to check the plots. And so you look at the scatter plot or the residual plot, either one, which is different than the plot of residuals, right? It's a scatter plot of residuals. And for linear, we're just looking for, is it not curved? We don't care if it's perfectly linear, we just care if it's not curved. And then you would look at that same plot for equal variance to see if it's evenly spread. Icing on a cake. If you want this fancy word, that is homoscedastic. Sometimes people like to use that word to impress people. You know, it really impresses the AP readers if you use that word correctly in your comments, but you don't have to. You could just say evenly spread. All right, so all of that we've done several times, and I hope that they're getting more and more familiar. It's a little harder to check conditions in this chapter, but the good news is on the AP test and on my quiz, you are likely to be given the graphs, and you just have to comment on which graph you're looking at to get each one. So then confidence interval formula is B plus or minus T star times SEB. Good news is that the B and the SEB are usually given to you on the computer output, and you just have to find T star, or if you're doing the calculator method on the TI-84, but not the 83, there is a linreg T int that you can use as your shortcut if you have data. So if you have data, you would use this shortcut. If you don't have data, you would be given computer output. T star, as always, is inverse T, which again is only available on the TI-84, but you could use the online methods that we've talked about if you don't have an 84. Hope you're really good at that, people who don't have an 84. You'd have the area under the curve and the DF, and remember the area is C plus half the extra, and DF is n minus 2 in this chapter. SEB, I'll put the formula for it, but I'm not going to make you use the formula on this quiz. If you need the formula, here it is. I pretty much have hardly ever used this formula, honestly. I know it because it's interesting, but I never need it. Or you find it next to the slope in the computer output. That is more likely to happen, actually. All right, I'm going to go sideways and then down. So the significance test, we're calculating what T is, and T is the sample slope minus 0 from your null hypothesis. Once again, this is almost always 0. And the only reason I'm writing that is once in a while it isn't. And so if that pops up, we'll talk about it. SEB goes on the bottom. Again, you'd be given these two numbers in the computer output. To find the p-value, you use df equals n minus 2, and the p-value is tcdf, T999df if you're going with greater than, or if it's less than, then you would be putting negative 999 first, and then t, and then df, or double it if it's a not equals. On the calculator, you would only use the calculator if you had lists of data instead of being given computer output. But if you're doing that, it's called a linreg t-test. And it will not tell you what SEB is, but you could find SEB, as I said before, by rearranging this formula. So like switch the t and the SEB, and you would get B over T. If you're using the calculator and you want to show work thoroughly, you would calculate it this way and then plug it into this formula. And that's more likely to happen on your next project instead of on a quiz. Because on a quiz, I think I'm just going to give you computer output. That's how it's normally done. Okay, you should be really good at this. It's that sentence we've done so many times before. We are whatever % confident that the true slope of blank and blank, those are our two variables, is between whatever your two numbers are. And then you can get even better than this. So we talked about this in one of the warm-ups when we did an example of this. It's even better if you can include the interpretation of slope in this sentence. I'll tell you how in just a sec. So if you think back to the one where we did the scores on the final versus the row number, you could say we're this confident that the true increase or decrease in score for each row is between this and this. Or with the helicopters, you could say we're 95% confident that the true time it takes to fall 1 foot would be between this and this. So that would be the including the interpretation of slope. Extra bonus for people listening to me and not just writing this down. Haha. P is less than alpha would cause us to reject. This is on a significance test again. If P is greater than or equal to alpha, then we do not reject. And we always include our justification and decision and context. And our sample sentence is since P is this, and then we would compare it to alpha. We reject or don't reject the null hypothesis that. And the easiest way to write this is that there is no relationship, or even better, there is no linear relationship between name your two variables. You could also say the null hypothesis that the true slope is 0, but you'd still have to name your variables in there somewhere. And possibly conclude that there is a relationship. I'm not going to write that part because I'm out of space. So there is your official chart and quiz on Wednesday, and then we start final reviewing. Yay!